Okay, quiet.
Good morning, everybody. It is my great privilege to introduce to you our AI seminar speaker, Dr. Raymond Mooney, who's been a professor at the Department of Computer Science at the University of Texas at Austin for 35 years. He's the director of UT's Artificial Intelligence Lab and has done extensive research in machine learning and natural language processing with over 200 published research papers. He's a fellow of AAAI, ACM, and ACL. Received the AAAI Classic Paper Award in 2019 and has won numerous Best Paper Awards. He's also my awesome former PhD advisor. Please extend a warm welcome to Ray Mooney.
I told Olfiata had a cute, humorous anecdote, and he didn't come up with one, so I'm disappointed. So I'm happy to be here today. How many people do we have online? Anyway. 20. Okay, for the few people here in person and the people online. So I'd like to talk about, so I don't know, I was asked to put this slide in my startup text. So I guess you guys know what's coming up. So I want to talk today about answering why questions about narrative text. And this is a problem I've been working on with some my colleagues at Stony Brook, the Naval Academy, and AI2, particularly PhD student Yash at Stony Brook, and his advisor, Naranjan, and Nate Chambers, who presumably a lot of you know at the Naval Academy, and the CAT at AI2. We started this whole thing as a part of the Kairos DARPA project, but it sort of veered away a little bit from the goals of the primary goals of Kairos. So there's been a lot of progress on question answering, right? Particularly with deep learning. We have lots of methods that have made a lot of significant progress on QA. However, most QA concerns who, I would argue, who, what, where, when sort of questions that have answers that you can sort of exactly extract from the text. Some QA data sets, you have to extract it directly from the text, like Squad or something. Answering why questions is less well studied and usually requires reasoning about and common sense knowledge that's not explicit in the text. You just can't extract something from the text to answer a why question. So I think it's a lot more interesting. So there are some of us who do go back a ways that remember the history, but for the younger folks, I want to do. I have to make a personal history connection here. There was a lot of historical work on story understanding in the 1970s and 80s. That a lot of people don't. You just have to be the old guy. Kids today don't read the old stuff. They should go back and read the papers from the 70s. I mean, it's like, now, Res, did you read this paper from like 1985 or something? Someone said, Ray, I wasn't even born then. It's like, what does that matter? Go read it. It'll come up again. But this work used a lot of sort of handcrafted knowledge based on good old-fashioned AI, right? You hand engineer these scripts and semantic parsers and stuff and get it to understand the hell out of like a couple of stories, but it doesn't generalize very well, right? It's very brittle. That was an old AI term. It's brittle, right? It breaks down to novel stories. It understands the hell out of the stories that it was sort of engineered and designed for, but it doesn't generalize very well to novel texts. So, is anyone here? NLP Idle, NACL 2012. Oh, yeah, I see it.
Where was it?
Montreal.
Nope.
Oh, crap. So, the NACL 2012, 11 years, not quite 11 years ago, right? It was in the summer. So they had this fun event called NLP Idle Plucked from Obscurity. That's the title that the program chairs came up with. Actually, one of the program chairs that got me involved in this used to be here. Anyone have a guess at that? She was here on sabbatical.
Doug?
From the University of Utah.
How?
Ellen Bila. She got me involved in this thing. The idea was you had 4 contestants that pitched an old, underappreciated paper that modern NLP researchers should reconsider. I competed with Eugene Charnier, that name came up earlier, Graham Hurst, and Mari Ostendorf. She's more of a speech person. I don't know her as well. And the 4 of us each had to select an old paper, make a quick pitch for it. I don't know, we had not 10 minutes, but more than 5, I forget. And then there was a panel of judges. I just remember Jason Eisner playing like he was Simon Cowell with asking obnoxious questions with a British accent. And then I was talking, Anyway, I forget the other judges. When I give this story, I should remember all the judges. Because he did this, so then I remember Jason. I actually picked the oldest paper. One joke I made in my talk is this: you don't have to be the oldest person on the panel to pick the oldest paper. I picked this Walensky paper from 1981, Pam Inside, which I learned in this textbook called Inside Computer Understanding, Schenker Riesbeck. I assume everybody knows that Roger died about a couple of months ago. What you might not know, where did Roger Schenck get his PhD? Anyone knows me, there's only two possible answers to that question. What?
Austin.
Boston, University of Texas, Linguistics Department, 1969. Who was his thesis advisor?
Oh, I could pick.
His name's Jacob May. He just died like a few weeks after Roger. He was 96 years old. He lived in Austin. Several of us here are descended from him. And they're now both, passed away just within the last, since this calendar year, both my academic grandfather and my academic great-grandfather, and for several of you put another grade in there. One more grade for Yolanda, two more grades for Kevin. I can do this all night day, ask anybody. One more grade for you, obviously. And two grades for Mike. No, one more grade for Mike.
No, two, because Wendy.
Oh, that's right. Oh, Mike corrected me on that. Oh, I never get corrected on academic genealogy, but you're absolutely right. That's tricky, though, because Mike's advisor was Wendy and not Roger. Okay. Some of you maybe actually even read this paper.
Some kind of weird cousin.
Anyway, who won? Who won? Hands down, both the judges and the audience. I wouldn't be putting this in the talk if I didn't win. Okay, so what was PAM for those people? It stood for Plan, Apply, or Mechanism, right? It constructed plan-based explanations of characters' actions and plans based on reasoning about their goals and plans. And these explanations allowed it to produce some interesting, pretty intuitive answers to why questions, right? So I picked this from that old textbook, that to scan it in and put it into PowerPoint. John wanted money. He got a gun. This is what stories look like in the 70s, right? He got a gun and walked into a liquor store. He told the owner that he wanted some money. The owner gave John the money and left. Why did John get a gun? Because John wanted to rob the liquor store. Why did John threaten the shopkeeper? Because John needed to get some money. Why did the shopkeeper give John the money? Because the shopkeeper didn't want to get hurt. Why did John leave? Because John didn't want to get caught. No, it all makes sense. But again, it's hand engineered with just the right knowledge structures to understand maybe a few stories about robbery or something. So then I come along. I did my PhD thesis in 1987, and I developed this system called Genesis. Something like generalizing explanations of stories into schemas or something like this, okay, which use PAM-like plan-based understanding to produce explanations of novel stories, and then tried to generalize those explanations into schemas or scripts based on those explanations. At least I know Mike knows this stuff. And did you ever read my thesis? Probably did. Yeah. So Mike even read my thesis on this. Classic example, you have to have your classic toy example in the 80s, right? So I learned a schema or a script for kidnapping by reading this one story and understanding it, explaining it, producing this graph explanation, explaining, eventually it accomplishes this goal of John getting $250,000. That was an effect of a bargain. These are all the preconditions of the bargain and a reasoning chain that supports that conclusion through a plans, and it uses strips operators for the plans and then horn clause inference rules and pieces that all together into this beautiful graph of explanation of how this story worked. And then it can answer why questions really, really well. Why did John aim the gun at Mary? So John could threaten to shoot Mary with the gun unless Mary went from John into the car. Why did Mary get into the car? Because Mary wanted not to be shot, and because Mary believed that I did really delicate modeling of beliefs in this. If Mary did not go from John into the car, then John would shoot Mary with the gun. Why did Fred give John the money? Because Fred believed that if Fred gave John the $250,000 trinas, then John would release Mary, because Fred wanted Mary to be free more than he wanted to have the $250,000. I don't even think GPT-4 could probably give as good answers. I should run these examples through, the current systems actually and see how good they do. We'll get to these details later. Yeah.
Did your system generate the text, or that's your own paraphrase of the system?
No, it generated the text.
Generated the word he down there?
What?
At the very bottom, it generated he.
You can see its pronominalization is not great. I had some, you're asking to remember crap from 1987, okay, right? But I did have some pronominalization in the generator, but it was obviously not that great. Okay. I don't know why it decided to actually put he there and it didn't like pronominalize Fred or something else. So yeah, pronominalization, interesting hard problem, not solved in 1987, believe it or not. I'm going to arguably not solved now, but we're obviously a hell of a lot closer. Okay, so that's the history lesson for those of you who I didn't live the history, you know.
So I did the same thing with economic sanctions, by the way.
Yeah.
I mean,
Yeah, good old fashioned AI. Remember that? Okay, now we rush forward to the 21st century. So this is my history of why I'm interested in why. So why you ask, why is Ray interested in why question answering? This was my answer to that question. It's deeply in my heart. I worked on it when I was 22 years old, started, which was unfortunately a long time ago. So now I got more interested in this sort of as a path through trying to do some things for Kairos. And together with my colleagues, mainly at Stony Brook, we worked on putting together a reasonably large-scale data set, at least by the standards of a couple of years ago, of why questions about short narratives with gold standard human answers. And we tried to determine how well current, now current is I was talking to Kevin, current is so dynamic right now. So just to preface all of this, I'm going to give you GPT-3 results. We are working on getting ChatGPT. You only had an API for ChatGPT just last week or something, what Turbo GPT something. Now, of course, we have what? Just as of yesterday?
GPT-4?
GPT-4, you know, I didn't even have time to put that one in the slides. So patience, I'll give you GPT-3 results. We are working now that there is an API to get at least chat. I didn't even know about GPT-4 when I just put these slides together 3 days ago. I knew it was coming, but it wasn't out yet. Okay, but we want to determine how well, quote, current large language models can answer these questions. And we developed methods for injecting relevant common sense knowledge from an existing knowledge base into such models in order to improve the performance. So the second bullet, there's an ACL paper, not last year, but the year before. And this third bullet point, there's a paper at EMNLP, just this last year in Abu Dhabi, if you want to look up the details on that, but I'll talk about it. Okay, so why questions? Here's one of the little samples. Do you want to know Rock Stories? It's a collection of stories that was built at Rochester. So we use that. Here's one of them where he's convinced of the bottled water. It all tastes the same. He went to the store and bought several popular brands. He went back home and set them all on the table. He spent several hours tasting them one by one. He came to the conclusion that they actually did taste different. Why did John Rudy go to the store and buy several brands? This is a human answer, I think. He wanted to taste test. So, you know, why does a lot, explains his motivation. You know, here's Shank again, you know, understanding plans, goals. What the original book was Plans, Goals, and Understanding. I have it on my shelf back in Austin. At least Mike's has this book. You know, another, my Stony Brook colleagues, they're not Shankian, so they put in this other reference from the 70s, Kinch, who's a psychologist who studies sort of story understanding and things. But, you know, this idea of our ability to understand why questions, this is old stuff, right? And people tried to do this in the 70s, right? But we don't have a large, at least when we did this a couple of years ago, there's really no large scale question for why questions about narratives. There's other why types of questions. I'm talking about why questions of narratives. You have a story, why did a person do something? Which is the typical Shankian type of thing that you would look at. So we built this thing we call TellMeWhy. You take Rock Stories, you ask people, we generated questions automatically about every action in the story, and then ask the question. We have 3 human judges on Mechanical Turk, generate answers, and then we have 3 additional judges that validate those answers by answering the question, is answer grammatical and is it valid on a 5-point Likert scale? And we did some filtering of stuff that was obviously garbage to try to maintain a pretty good corpus. And, you know, we tried to do this right, do a good analysis of the quality of this data. Human judges rated 99% of the answers grammatical from other humans. They rated 95.5% of answers valid. We tried to define, you know, this is a reasonable answer to why that person would do that. We had judge, of course, in our annotator agreement using Fleisch Kappa, got like 0.88 for grammaticality, 0.81 for validity. So this is a pretty good cleaned up data set I think you can trust. We tried to do, you know, due diligence on making sure about that. Some characteristics, so we ended up with about 30,000 questions over about 9,600 stories. So decent, not humongous, but decent, I would argue. We made this distinction. We had humans actually mark questions of whether they felt you could explicitly answer the question from what was literally stated in the text, or whether it was sort of implicit you had to make some inferences. Now, again, I don't know if we judged human agreement on this decision, But, you know, people would say like, well, 30% of the questions you had, the answer really wasn't in the text. You sort of had to use your common sense knowledge or reasoning to come up with an answer. And then 71% they said it was. Now this judge, I wonder, you have to ask Yash, did we do human agreement on this distinction? I don't know. Because it can be a little bit fuzzy. And we also looked at just to see if there were diversity in the answers. We looked at the token overlap between Turker's answers to the same question. So there's a certain amount of token diversity, you know, because there are different ways to answer why questions. There's not just one right answer, which is why we put 3 into the gold standard. Okay, so the code and the data and everything else is available at this Stony Brook GitHub. So I might pause here if there's any question just about the data set. Yeah,
Can I ask you, the disagreements between the human responders were due because, as you said, there's different why answers?
I wouldn't even call it disagreement, difference, so it may be.
Okay, okay.
I don't know if we've done an in-depth analysis of that diversity of answers to why questions. This is something we've talked a lot about, but I don't have any good data on that, but it's an interesting question because unlike a lot of when, where, who questions, there's a lot more possible correct diversity in why answers. And I think that is an issue that could be dug into more deeply, maybe using some issues from using this data. But no, it's a good question.
Did your annotation standards try to exclude, say, pragmatically invalid why answers or overly speculative? Those are kind of two.
We just asked humans to judge these
Just say why.
answers.
Okay.
Yeah, we didn't give them too much instruction. We defined what we meant by a valid answer a little bit. Again, this is where, you know, it'd be good to have the grad student here to tell you, oh, here's the exact, you know, Turk instructions. But no, we didn't go, because you can't, these are Turkers, right? We're not asking them to make fine linguistically, you know, deep distinctions.
Mm-hmm. Similarly, I know it may be hard, but have you looked at like kind of inter-annotator agreement or?
Oh, no, so I gave you the numbers for that.
Okay, wait, 88? Is it?
Does that mean you just ask people, is this a correct answer? And they say yes or no?
Yeah, and then we had 3 judges do that. What was the inter-annotator agreement between the judges judging the grammatical and semantic validity?
Semantic
and-
validity was.
Yeah, well, that's what validity is here.
Well, it is, yes.
Yeah, it's 81. So it's a little bit less for the semantic versus the grammatical, but no, it's pretty good, right? It's
Yeah,
flash cap
that's
of
like-
0.81.
Actually, it's much better than simple labeling tasks. Even.
Yeah. So that's what I'm saying. I
So
think we try to do
subjectivity is
good
not
due
a big
diligence. This is data that's pretty clean and trustworthy, I think, but you know, thanks for clarifying that. Okay, so that's the data set. So a couple of years ago, well, not a year and a half ago or something, we benchmarked this with reasonable models at that time, T5 and unified QA. We fine-tuned the pre-trained models on the TellMeWhy corpus using like 23,000 trained, 3,000 dev. As with human answers, we asked 3 human judges to evaluate the system answers on 664, I don't know why that was chosen, hidden test questions for grammaticality and validity, just like we asked the Turkers to judge the human answers. Exact same interface, in fact, I think. Okay, here were the results in terms of this is what percentage of the answers generated by the model were judged as valid, which means a positive Likert scale. We actually ranged the Likert scale from -2 to 2. So if it was a +1 or a +2, we said, yeah, it's a valid answer. And humans are at like, you know, like 95% or something here. T5 was getting like 50, unified QA maybe a little bit better. So not that great. Not horrible, but not that great. This is breaking it down by what we call the full test and then just implicit, where the answer is not explicitly in the text. And humans do maybe pretty much the same, but the models you see, when humans say that the answer requires some reasoning and going outside the literal text, not surprisingly, the models do worse. What did that comment say? Sorry, I wasn't expecting that. Yeah, so fine-tuning large QA models isn't enough. Argument was at that point, this is a year and a half ago. I'll get to more recent results. So automated metrics versus human eval. Evaluating answers to why questions is difficult and requires human judgment. This is my claim. We tested 3 automated metrics to compare generated answers to human answers and correlated them with human judgments. We tried BLA, BLERT, and BERT score. I know people know those scores. If you don't, you can read up on the details. Obviously, the last 2, everyone knows BLA, right? Was that invented here, actually?
No, IBM.
IBM. Sorry, yeah. I don't know what I was thinking.
Would have called it.
It's funny because I remember first talking, when I visited here, when this first came out, I talked to Ed Hovey about it
There was a ruse that was discovered.
here.
Or
Okay.
developed here.
But now I remember talking
Yeah,
to Ed about Blue when it first came out, when I happened to be visiting there shortly after Blue came out. That's why I think that was misfiring was going on in my brain. So, these are these correlations. They're not negligible, but they're not great, right? Like maybe a 0.3 correlation with human at the best, Spearman. And so they're telling you something, but they're not really, you have to go to humans for this problem. This is my, developing better automated metrics for these sorts of tasks, interesting question. But the current metrics, they're positively correlated, but not extremely high with human. BERT score is the most reliable, but just, slightly better than BLERT. Okay, so that's sort of part one. That was in the ACL paper from a year and a half ago. Now into our more recent stuff, our MNLP paper from Abu Dhabi. Who was in Abu Dhabi? Yeah, John was there. How can we use common sense knowledge for QA? So what aspects of common sense knowledge are already accessible in these large language models? That's a big question that everybody talks about, right? What aspects can be made accessible by explicitly injecting information from relevant knowledge sources? We looked at this issue. What kinds of knowledge still remain inaccessible? That I'm not going to have a lot to say. We tried to analyze this, didn't come up with anything. I actually took that part out of the talk because I don't think we had any good conclusions about that. Okay, let's make the model bigger, obviously. So T5 base, I think usually people call it, I think that's what we called it, 110 million parameters. That's like a nano model by today's standards or something, right? So we went to at least 11 billion, T5 11 billion. How much does it get better going to 11 billion parameters versus 110 million? Then we tried to look at even larger models like GPT-3, Lambda, Palm, and again, this slide's a little bit dated. So we tested GPT-3, which has about 175 billion, zero shot, since it's hard to fine tune. I don't know, can anybody fine tune?
Need money.
Yeah, enough money maybe. We're academics. We don't have the money to fine tune, but let's do it zero shot, way that most people do. Few shot, keep that question on hold. We'll get back to it. So here's now we know T5 base. This is the average Likert score. I'm changing the metrics here a little bit. The Likert score ranging from -2 to 2, and this is the average human Likert score for an answer from a model. T5 base, like I said, was under 50%, under 0.5 on the Likert scale. I'm sorry. Yeah, size matters. 11 billion, you're up to 1 point. This is a positive, on our average, the humans like their answers reasonably well. GPT-3, zero shot. So you can't really, these are not really apples and apples. They're a bit apples and oranges because this is fine-tuned on our data. This is GPT-3 out of the box, zero shot. We played a little round with the prompt. And don't ask me about details of the prompt engineering. I'd have to talk to Yash about that. He played around with a few things and tried to get this to work as well as we could.
Is that the instruct GPT-3?
No.
3.5.
Yeah, 3 point, yeah. Okay. Well, not even 3.5.
Oh, yeah.
Good old
Actually, so do you
fashioned.
know what specific model? Da Vinci?
Da Vinci.
Yeah, it could be.
Yeah, this is where I need the student here. Da
Instructed
Vinci
03.
something, but
Yeah,
not struct.
02 or 03 or 01.
Oh, okay, sorry.
Might have
I can
something
get back to you on that. It's probably in the paper. The students do the real work. I haven't written code, unfortunately, in quite a while. This is the implicit, where you have to reason or something. T5 base isn't even positive, and these are getting positive. So some common sense knowledge is in these models, I would argue, from these results. So larger models do seem to exhibit aspects of common sense knowledge that allow them to answer questions that require inferring content not directly given in the story.
Wait, can you go back to the other slide? I mean, one thing is the difference. Is it like, can you say the GPT is actually doing better? I mean, is the difference actually?
We did stat sig on some of these results. I wouldn't claim that from this result, but there might be something in the paper that talks about that. But remember, this is zero shot versus fine tune, so it's really not a fair comparison anyway. So I would say the fact that GPT-3 is zero shot and this is a fine tune result, clearly it's better. Mm-hmm. By some definition of better.
Or it can perform at least as well on zero shot.
At least as well. Oh, no, at least as well, that's clear. Right. They can do as well on zero shot as T5 can do fine tune. That's a firm conclusion. Yeah. How can we add common sense to these models? This is something we talked about. It took us a year to get this to work. We had this idea because I talked to my good friend, Yejin Choi. We all know Yejin, right? MacArthur Prize. She's officially a genius now. I still remember when she was a struggling faculty member at Stony Brook. And she thanks me for the help I gave her. But how can we add, she told me, I was talking to her about COMET. People know COMET. It's this sort of combination of good old-fashioned knowledge engineering plus deep learning. If you don't know it, I really like it. It's a couple years old now, but it's a transformer-based model that learns to make common sense inferences by training on human-engineered common sense knowledge from atomic and concept. Now, concept was their previous hand-built knowledge base, but then they built a transformer on top of it to sort of learn from human common sense knowledge to generalize its ability to generate common sense inferences. I think that's a fair characterization. I don't know if people know COMET. It's worth looking at. It's sort of an interesting system, I think. So can we add that sort of knowledge from COMET to make this better? And we tried lots of ways of doing this, but here's an example of a common inference that you can make that adds ability to answer why questions. So this is a new story. I'll read it. Sharon slept right through her alarm clock. She was dreaming of the ocean and how the waves sounded. She didn't even hear her family leave for church. When she woke up and everyone was gone, she was afraid. She couldn't believe they got gone without her. Why did Sharon sleep right through her alarm clock? You give that to COMET, and you can give COMET sentences, and it'll make common sense inferences from that of various types. What is the cause of that? What is an effect? What is it hindered by? What's the last sub-event? They had some ontology of semantic relations that they can make inferences about. But if you look at human answers say Sharon slept through her alarm clock because she was having a dream about the ocean. 2, Sharon had been sleeping deeply. She was in a deep sleep and dreaming of sound waves. What are one of the inferences from COMET? One of the inferences from if you slept through your alarm clock, person X was in a deep sleep. That's a very useful inference to match very closely these two human answers. Okay? So I think you can use inferences from this sort of knowledge base to add to the content of the document and then use that additional content to help answer the question. So then we played around, us and the students did most of this work, tried several ways for determining which and how many common inferences add. There's a lot more details on this in the MNLP paper in December if you want to look at it. We found that adding the 3 top scoring inferences from COMET that come from different relations to give it some diversity, you pick the top 3, but you don't put all in the same relation from COMET. You try different relations to sort of give some more diversity in the inferences. And that ensures that sort of high confidence, diverse knowledge is added. And we played a lot of ways. There's details of the games we played to try to figure out which and how many to add from COMET. We found that adding the knowledge-based inferences to the input story right after the questioned event used to generate it worked the best for GPT-3, but adding them at the end of the story worked for T5. We played around with all sorts of ways to stick this content into the story. Where in the story should we put it? We tried making the inferences with formal COMET relations or, quote, verbalizing or make it sound more like everyday ordinary English. Not surprising, we found the latter worked better. So here, sample knowledge format, this is for T5. You get this thing, this is like the tags in there, has last sub-event, but you're fine-tuning it on this, right? So maybe it can learn the COMET relations and how to use that knowledge based on the COMET relation. Not surprisingly, we found if we had some simple generation to generate those common sense relations from COMET into ordinary everyday English. So it says Sharon slept right through her alarm clock, ends with she was in a deep sleep, which is a weird way, but it comes from the relation type that, so some of this is awkward English, but it's better than just putting in the formal expression from COMET. So here's some results on adding knowledge. So T5 base, if you add the knowledge in the tuple base, you get a little bit better. I forget where I should have the original without knowledge form. We'll see that later. But you know, get the verbalized definitely does. This is just to show, I think, that the verbalized form is better than just putting the COMET-based relation version in, which is not too surprising. That's on the implicit. Anyway, verbalizing we found. We did a lot of experience to say, what's the best way to figure out how to put this COMET knowledge into the story? And we did a lot of work on that. The details are in the paper. Now, let's look at the final results, though. We found the best way to add the knowledge in, and then we saw how it impacted performance. So T5 11 billion goes up a little bit from an average Likert of 1.21 to 1.27. GPT-3 actually benefits more from this COMET common sense inferences. Goes from 1.17 average Likert to 1.31. Humans, if you look at their average Likert rating of human answers, human ratings of human answers, it's like 1.35. It's like, wow, we're getting pretty close here, right? And again, pause on the chat GPT, GPT-4. That would be interesting to see. This is implicit. Everything's a little bit worse, but the same trends. Okay, now, big question. Yeah, Mike.
So I understand why, but you also had to limit the amount and type of knowledge that you added, which is sort of different. From people
Well,
like
because, you
us.
know, for these models, you can't just throw everything into the context window. It's going to get overwhelmed. That's why we played around with how much.
It's a little disappointing, but I understand.
Yeah. Again, you know, we just pragmatically tried to figure out the best way with these current models, how to put this knowledge in. And, you know, the details of all the things we tried, not all the things we tried, but a lot of things we tried, experiments we, you know, hopefully if I'm known for anything, I try to do good empirical work. So the average Likert score for the largest models with COMET knowledge added are getting pretty close to human. But what? Let's break this down. Let's just break it into binary. Just to say it's valid if it's rated +2 or +1. It's given 0 otherwise. Humans are still quite a bit better. We'll look at this. If we just binarize it. This is due to the models achieving more +2s than humans, but also more 0s, -1s, and -2s. And we'll look at the actual breakdown in a minute. I think it's interesting. So here, if we just look at binary accuracy, we just bin these into two Likert, five-way Likert number, just into two, positive or not positive. Whoa, now humans are at 99%. The model GPT-3, this is with knowledge, I think, is down to 89. Doesn't quite look as good. It's good, but not as good. And look at this. Wow, the models are coming up with invalid answers, much more likely than humans. Humans rate human answers invalid only 1% of the time, where here we're getting 11, 14%. There's a reasonable amount of model answers that are just bad. Yeah.
Does your setup allow for the answer to be, I don't know?
I guess they could type that in principle, but no, it's not an explicit choice. You have to come up with some reason.
Not a choice. It's free text, right?
Right, yeah.
Could an annotator judge this as, yeah, it's correct that the explanation is you don't know? I don't know either. That kind
We could look into the data if anyone actually has answers is I don't know, or your guess is good as mine, or something like that. I mean, the fact that there's pretty good inter-annotator agreement would definitely tell me there's not a lot of that, unless everyone decided that they should say, I don't know, to the answer. But no, it's an interesting question. I would argue, I think, anyway, again, this is where you need, as a grad student who maybe knows the data a little bit better than me, but I would say no, that we really encourage them strongly to, at least make some inference about why you think the person's doing it, even though, this is why I hate ChatGPT, because it'll just refuse to answer things. We gave it restaurant, don't even start me on a whole ChatGPT, but we gave it the standard restaurant thing. Man went into the thing, ordered a steak, he left, and yes, what did he eat? And I go, I don't know, he didn't say he ate it, right? But well, if you had to, what would you say he ate? If you really push it, it'll say, yeah, he probably ate a steak, but people are not like this, right? They don't even remember what they read. There's good experimental results in psychology going back to the 70s. I took psychology of language with Bill Brewer at the University of Illinois. People don't even remember what they read and what they inferred when the inference is really strong. They wouldn't remember whether you said they ate the steak or not. But ChatGPT, it's been trained to be very cautious, right? It's like, I'm not going to make any inferences here. It's like not the way humans understand text, I would argue. Implicit, the difference is even a little bit more. Here's, I think, the most interesting result. This is the actual distribution of Likert scales from different models and humans. Look at the model here. It's getting more +2s. GPT-3 with COMET knowledge, 52% of the answers are getting +2s. Humans are only at, Humans are at 44%. But humans get +1s a lot more, 55%. Whoa, the +1s are going down for G, but now, 0, -1, -2. Humans, almost very little, but the model still has some distribution down here. A reasonable number of zeros, some -1s, some -2s. I think this is interesting to look at. It's not to look at the average. Let's look at the actual breakdown of the types of answers. So we tried to dig into this. And implicit, this is even more pronounced, that there are more negative answers and 0 answers from the models, not surprisingly. So here's some actual examples. So here's a highly rated GPT-3 with COMET knowledge answer. Matt and Sarah were pregnant. They wanted to announce it in a fun way. They wrote it on a cake. Then they invited their friends over. When their friends saw the cake, they were excited. Why did they write it? Without COMET, GPT-3 says they wrote it on a cake. Whoa, 0, that should not be 0. That should be like negative or something. I think this is the average. I don't know how Yash gave me the results, because we have 3 human ratings. Maybe this is just like one of the ratings. But anyway, model answer with the COMET knowledge to let their friends know that they were expecting a baby. Not bad. Human answer, Matt and Sarah wanted to surprise their friends with something unexpected. I was given a +1. But sometimes the model does really good, particularly if you add COMET knowledge. So here's a sampling highly rated answer without COMET. Same story. Why were Matt and Sarah pregnant? Model, Matt and Sarah were pregnant because they wanted to have a baby. Never says that in the story. That's without COMET. It's making that inference given its own common sense knowledge. Sort of cool. Human answer, the two of them had previously been intimate together. I'd actually argue this is like what I think philosophers would call what the immediate cause, and this is sort of the deeper cause. What's a proximate cause and whatever. This is sort of a deeper answer. The model's answer in some sense is semantically deeper than the human's answer.
Might not be true. Also.
We always make inferences when we're reading text. Sample poorly rated GPT-3 answer. This is with knowledge even, I think. Maggie was drinking some green juice. She left the cup out a while. When she went to get another sip, it tasted odd. She realized that it had separated weirdly. She threw the juice out. Why did she leave the cup? Model answer. Maggie left the cup because it was too heavy. It's like, WTF?
Do you know if that got into the COMET? Do you know if that got into the augmented input? Something about heaviness, like if it was a bad retrieval?
That's an interesting question. We could dig into the reason why it generated that and what the answer was with and without knowledge. We would have that obviously, but I just put this in. But I think this is the best model, which is the one with the knowledge. The error you're saying could have come from a bad COMET inference. That's possible.
Well, right. So you have the hallucination.
But we have the aggregate results that show on average, this is true. But this specific example, we'd have to dig into the details. But humans, they make up a good answer, right? There was something else Maggie had to attend to for a bit. Never says that, but humans say, yeah, +1, pretty good answer. Okay, so now I'm trying to push this as my new quotable opinion. Sometimes large language models surprise you how smart they are, and sometimes they surprise you how stupid they are. So when I showed this to these initial slides, I made this for NLPCC. People know what that is, the Chinese Natural Language Project. I gave a virtual invited keynote talk last October. I made these slides up. I passed them by Niranjan, my colleague at Stony Brook. He said, Ray, that's not funny. It's not as impactful as your really famous quotable statement that I made at ACL 2014 semantic parsing workshop that became a meme. I tell people, they're going to carve this on my gravestone. You can't cram the meaning of a whole blankety blank sentence into a single blankety blank vector. And so he said, yeah, you need to put some fake profanity in this thing to have more impact. So now my quote that I want you to quote is, sometimes large language models surprise you how smart they are, and sometimes they surprise you how blankety blank stupid they are. I always say when I do this, I say, use your language model of common vernacular American English to fill in the mass portion of the sentence. This is why I told Ulf I would teach him a new word today. So he's expecting this. My colleague, Katrin Erk, actually found that when you use these punctuation marks as profanity, it actually has a word. It's called a grolix.
Yeah.
You knew this?
I knew that.
Holy crap. This is now my favorite word in American English.
I never heard that.
I thought if anyone here knew it, all knowing it is the least surprising, but it's still surprising that he heard this term before.
She worked in this for a little bit.
You sure you didn't read my slides on the web or watch my talk from NLPCC? Yep. I wonder. Okay, so that's my bottom line conclusion so far. Okay, few shot learning. I said I'd get back to GPT results are handicapped because they're zero shot. But these are large sort of quote closed models. I told Ulf I'd use my joke that open AI should be renamed what? Closed AI. They cannot be easily fine-tuned on the data. So we can do few shot in context learning though, right? In which a few training examples are given to the prompt, and that's been shown, we all know, to improve a lot of these problems on with large language models. I tried to get Yash to give me some new results on this. He's been trying this. We're playing around with prompt engineering, which we all know is really critical. Right now, we're not getting any advantage from few shot learning on this problem. This is definitely preliminary because we haven't, I think, done the full prompt engineering to see how well we can do. But right now, initially out of the box, we can't get few shot learning to help on this problem. And of course, this is all old news, right? Because who the hell cares about ChatGPT-3 anymore? I mean, who cares about GPT-3 anymore? Sorry, we got to do ChatGPT, Turbo something, GPT-4, whatever. You know, he's busy, you know, Stony Brook is busy. He couldn't get me answers in time for this talk. Some other things we've been thinking about, exploring other types of why questions. In particular, we've been looking at why questions about instructional text. Particularly, we've been asking, we give it an instructional text like a recipe, and then ask, why does this step have to come before that step? The models currently that we've tried, it doesn't answer these questions well at all. This is just really, really preliminary. We haven't even collected any human data on this. It's like, you know, the grad student trying out some things, looking at some things. We did like 50 examples or something. You ask the instructional text, why did this step come before that? Why did that step come after that step? You know, in humans, you can generate pretty good things. And the models, well, generate some good things, but mostly not able to understand why you do things in the order that you do in instructional text. We're also exploring how training on other related tasks, some people know social IQA, can help answer questions in TellMeWhy, and how training on TellMeWhy can help some other data sets. We have some preliminary positive results on this and how training on TellMeWhy can help things like social IQA and maybe vice versa. Okay, so to wrap up, where am I on time? Good?
Yeah, we have actually
Yeah, I talk
a
fast.
couple more minutes, yeah.
Yeah, so I want to leave plenty of time for questions and discussion. So answering why questions about narratives, I think, is an important and challenging problem. It's an old problem. I worked on it 40 years ago, I started working on this problem. I'm still working on it, but I'm retiring in 4 years. We developed a large benchmark data set for that task together with an easily deployed human evaluation. Nobody else tests on this data set. Why? Because they're lazy bastards that don't want to do human evaluation. They all seen me get wild about a couple of topics the last couple of days I said that.
Sure.
Don't start me on people not wanting to do human eval. We've made it easy. You can run a script to generate the hits. We just have to generate the hits and run the hits yourself. People don't want to, I don't want to do human eval. That's too much work. I just want to run a script and get a number out that I can publish in my paper. You know? Sorry, you can tell I have buttons, boy, and that's a big button you can push.
Push your own button.
I push my own button.
Online, they're missing half the show.
We have developed a large where am I? Large language models, if large enough, can do fairly well on this task. I would argue, at least as of GPT-3, we're not there yet. We're getting close, but we're not there yet. We developed an approach to adding external common sense knowledge that does improve performance. This can be useful. How much less useful it is with the even bigger modern models, you know, stay tuned. The best models produce more high quality answers than humans, but also more low quality answers. Okay.
Thank you very much. So we have a good bit of time for questions. First one we got from Pat Langley, in fact, regarding one of the earlier slides, and it actually refers to UT.
Hey, Pat.
UT Austin. Can current QA systems produce the types of biological explanations found in Jeff Rickles' thesis, 1990?
Jeff.
He didn't focus on
Bruce Porter students at UT alum.
He didn't focus on language, but he did handle complex reasoning chains.
So I think why for narrative is, that's why I clearly titled my talk and everything I said, why questions about narrative text. I said in the thing, why questions about other sorts of things? You know, why is the sky blue? You know, why do I do this step in cooking before that? I mean, there's all sorts of other, you know, why. And I'm not, you know, interesting question. Expanding why to other types of why questions, interesting, important problem. I'm focusing here on why on narrative text, which is the classic Shankian sort of thing to do.
Any questions here from this audience?
I have a question about the human evaluation. I sort of agree with it, except the easily deployed part. So easily deployed means you get idiots on Turk, as opposed to journalists telling you whether.
But they agree with each other 80.
Yeah, but if you ask journalists why this is fake news, it's different than when if you ask a Turk.
But that's a different type of why question. I mean, this is why about everyday activities.
Yeah,
I think I wouldn't do, you know, answer questions about medical texts on Turk.
Okay.
But this is everyday ordinary stories that ordinary everyday people should be able to answer, and they do agree with each other reasonably well.
Do they agree with you when you take a sample?
Yeah.
All right.
You know,
Because there was
it'd be good to ask some of the students that actually looked at the data more than I have.
There was a paper I just was recently reading about decrease in quality of Amazon Turkers.
Oh.
Valid answers went
Yeah.
from like 98% to like 2%, but they were actually blaming language fluency and cultural competency.
But we do a human filtering of the human answers. I went through, we tried to be careful with this data set, right? And so that gets filtered, hopefully the real crap gets filtered out in that step.
But people don't understand the cultural kind of the.
And hopefully those answers get, then they have 3 judges that are judging other humans. I mean, the data is filtered pretty well, I would argue.
Well, I guess what I'm getting at is for some tasks, maybe not this one, I would prefer you use a smaller number of more qualified people to answer the question.
For different types of questions, I absolutely totally agree with you. I'm just defending this methodology for why questions about simple rock stories.
Okay.
Well, I don't know, when you say you're using Mechanical Turk, it depends, there's a question of how you're using it, right? So you can recruit people through a Turker Nation Slack channel and curate them, and essentially you've got employees that you're just paying by a weird way. Or
I think the
you can
main
get a
way we
bunch of
tried to do
random
quality control here was having the human evaluation of the human
Do you
results.
know how many unique Turkers you have? Is it in the thousands or is it in the tens?
Yash would have the numbers on this.
But I would.
We did limit how many people, how many of these in the individual person. We did work about that issue, obviously. There is diversity in the Turker pool.
No, I'm not arguing for the opposite. I'm saying that if you get a huge pool of Turkers, you're more likely, you're not curating them well, generally.
But humans are judging those answers.
Yeah, but it's better to get 10 good ones than to get.
I don't know for this problem, because I want diversity of answers. And so,
For generating, maybe. I'm talking about for binary evaluation.
okay.
But even
Oh.
generating it.
Oh, you're saying not the generating the answers part, but the judging the answer
Yeah,
part.
to get
Okay,
that-
fair point for that. I wouldn't want to do that for the generating the answers, but for judging the answers, I'm on board. Yeah. Get a really good set of people to judge those answers and keep them. Fine. Fair point.
So I guess what I was getting at, if I were ranting in front of the room.
Mike saw me do this 20, 30
I
years
know.
ago, so he knows.
It would be the people who get Mechanical Turkers to act like AI systems and then evaluate. Choose the 3 words of this review that most tell you
Yeah.
it's a fake review. Well, as opposed to, why is this a fake review? So it's a separate rant and maybe not as appropriate for your talk.
Well, no, I agree with you, though. I think people don't want to use humans when they need to, and they want to make things simple and automated or whatever, and it destroys the quality of the evaluation. So I don't think we're disagreeing.
So I guess my question is NLP research over? Let me just.
Oh my God. I mentioned.
Let me just.
Okay, sorry.
I think everybody knows what I mean, but
I don't.
Working on tasks like, let me just take machine translation. So GPT-3 does a good job of machine translation, better than Google Translate on high resource languages, not as good on low resource. But when you think about the future of machine translation, I wonder, is it going to get better because people are working on machine translation like they've been doing for the past 50 years?
You get more data.
Is it going to get better because these big brains are being built in a more appropriate way and smarter and bigger? So, I'd be nervous, I guess, that if all the results are going to come from these big brains, that working on specific tasks like machine translation or why questions or whatnot, is going to get steamrolled by these more general techniques.
Yeah, so these big questions are interesting. I'll point you to a link on my homepage. I gave this talk at UT at the beginning of the semester. It's the videos online. We had some good discussion. The new era of big science AI. How can academics adapt to the new reality? I think Kevin and I were talking about this morning. So if you want to hear my thoughts on this, maybe I'll just point you to that link, But it's a weird time. One of the things that Peter Stone asked me in that, because we just say he started grad school in 93. I started in 83. So he's 30 years into this. I'm 40 years into this. Mike and I are about the same generation, And this is new. I assume Mike would agree with me. It is an interesting time. May you live in an interesting time, right? It's like, this is unprecedented. So yeah, and I told her, I said, I'm out of here in 4 years, good luck. I still want to hang in there for 4 more years. But where are we going and oh my God, big questions. Anyway, I try to sort of address some of these issues here if you want to watch it. Yeah.
The scary part is it's harder and harder for people in academia to compete. Yeah, I'll watch that.
Watch the talk.
One more question from online, if I may, from Paving Wang. One problem with COMET is that the knowledge inferred by it is not contextualized. For certain relations, there could be multiple valid inferences. How do you address this?
Yeah.
You just throw the whole story to COMET?
Good question. No, we tried different things. There's what's called paragraph commenters. There's various versions of COMET, I'll first say. And we tried different things. I think the thing we found worked best was just to give it, it gives the whole story as context. Yeah, boy, see, this is where you really need to tune into the details, but I'm pretty sure, yeah, we gave it the whole story as context and then ask it to make an inference from that statement or something. And we played around with it, but this is a good question. Maybe if you ping me or whatever, we can pass it to Yash and get a better answer to this. But it's an interesting, it's a good question, and we played around with this a little bit, but maybe let's take that offline.
I'm sorry, I might have missed it. Where did the stories come from?
Rock stories.
Those are rock stories that you're using, just the 5-line thingies.
Yeah. Yeah, Yolanda.
So imagine you had infinite amount of time, not just for years or however long. Imagine that you had infinite amount of time and infinite amount of resources.
Money, yeah, this is like
What is your best foot forward if you were to recommend the AI community or you yourself pursue this to combine all of these, more targeted symbolic knowledge about common sense and these, more organic language models. So how do you think that these things are going to work?
Yeah, it's a good big question. And I usually, pitch the generic sort of neurosymbolic sort of approach. So when I gave a talk at some language and vision workshop at NeurIPS like 5 years ago or something. I had recently read Thinking Fast and Slow. We all read this book, and I pitched this thing, and I've seen other people do it. It's not rocket science to make this analogy. I've seen other people make it, but I think I made it before anybody else. And so no, that's a really good at thinking fast, right? The sort of pattern recognition sort of things. Good old fashioned AI is better at the sort of thinking slow sort of thing, methodical sort of reasoning. And, not surprisingly, I think we really need to figure out how to integrate those two. There's a lot of people in the community agree with me. I mean, Josh Tannenbaum gave a nice talk at ACL. Josh and I see very much eye to eye on this issue. We've actually had the discussion that, in my lifetime, I've seen sort of 3 paradigms of AI. I was raised in the sort of symbolic AI paradigm. I've done work in the neural paradigm. I did neural symbolic stuff in the early 90s. I mean, maybe Mike even remembers this stuff, integrating certain effector rule bases with back propagation, right? I've been trying to integrate good old-fashioned symbolic and AI and neural nets longer, arguably, than just about anybody, right? So obviously, I care about that issue, and I think it's a deep and interesting issue. But then there's the Bayesian paradigm, right? Which I've done work in Bayesian. I've read Bayesian papers, neural net papers, symbolic papers. I think, for someone of my generation, I've done a wider variety of things than most people, right? And I appreciate the contribution that all 3 of those perspectives bring to AI. And I know this is something that, say, Josh and I completely agree on. Somehow we have to figure out how to synthesize the insights of all 3 of these paradigms. They all have something important and interesting to offer in both of building AI systems and understanding human cognition. Do I have some great idea about really how to do the ultimate, unified theory of AI or something? Maybe I wouldn't retire in 4 years if I did. But yeah, so I love the spirit of it. I believe in the spirit of it. Do I have detailed technicalized ideas of how we actually pull off this integration? I look forward to all of us working together in the future together to make the world a better place. I love that line, Silicon Valley.
Actually, now that you brought up thinking fast and slow, actually, that kind of remind me of the question I've been wondering about, so human brain has this uses cognitive heuristics to make these quick decisions. And there is an evolutionary basis for that because we don't have the time or capacity of processes. So I was wondering what kind of, like if in these language models have similar, like this type of biases.
Evolution is learned, right? I mean,
so what kind of biases do you envision, like would you test for these sort of large language models to have? On kind of in analogy with human cognitive biases?
I think there is a lot of investigation of that already, right? I mean, it's sort of the standard, arguments that people criticize large language models, right? They get from the data. So any biases that are in the data, it's a dumb answer, right? Or simple answer, not it's right, but it's simplistic. Is whatever biases are in the data, these models are going to absorb, right? Duh. You know.
So that's what about the shortcuts people take with computation? Is there some type of biases that come like in analogy with human brain not being able to process data in real time?
No, I mean, again, everyone's open to opinions on this. I think that's less of an issue. I think, I was raised more as a machine learning person than an NLP person. I've always been on the boundary. I think, Mike and I are similar in that way. I think it's more about the data. It's like I used to teach machine learning 30 years ago. I said, there's no data like more data. But I was telling Alf, I call myself a hard-ass empiricist. I really believe in data that matters, And so I think a lot of algorithm, I can pontificate hours. We should go to lunch at some point. Alf's been listening to me pontificate for 2 days. I understand with it. Yeah, so these are big questions. I appreciate it. Obviously, I have my opinions on that. Oh, I know what I was going to say. Why has deep learning succeeded? Number one answer, data. Number two answer, GPUs. Then I used to say maybe a tiny epsilon of algorithmic improvement. Then someone got me to replace it with 3 good software support infrastructure. Thank you, Hugging Face. My former PhD, Nazneen Rajani, works there. She just gave an invited keynote talk in MNLP about all the work at Hugging Face, right? So now I say 3 good software infrastructure. 4, a little bit of interesting algorithmic development.
So it's not
Do you
the
like this one?
architecture.
This is one of my standard pitches these days. Yeah.
Not the models, not the architecture.
Yeah, all of these matter. Don't get me wrong. All of these matter. Data first, compute second, good software infrastructure 3, and a modicum of smart algorithmic development. CNNs go back to the early 90s, LSTMs to the late, okay, transformers. That's actually something new. So the algorithms aren't 0, but they're 4th. I don't know if people agree with me on this. I don't think this is a controversial statement, right?
I'm just wondering when you can put the next one in. It's a nice.
5. People have an example of 5. I don't know what 5 is.
So I'd actually add code sharing and the number of people in the field. So
Okay, number of people in the field is new. I would put the first one under 3.
Okay, but now there's thousands of people doing CNNs for image processing
absolutely.
instead of 7.
So 5. No. I don't. Where does that belong?
Does it start at work?
Maybe that's 1 actually. No, it's 2. I'll put it 2.
Yeah.
No,
I'll put
that's
it 2.
software engineering.
More people.
How do you think that helps?
More people. It's just parallel search.
Parallel search of what? Models?
Yeah, everything. Not parallel search of data, algorithms, better systems, everything.
Better what?
More people.
Applications. So I'm working on
Applications.
glaucoma. It works really well on 4 data sets, doesn't work well on 1 data.
Okay, you got me to change it. Data, people, hardware, software, and algorithms. Thank you. I'm up to 5 now. I put it number 2, actually. I go for number 2.
I have a 6. So what I see in science, and that's why I asked you this question, I see in science is theory guided machine learning.
Oh, wow.
Right?
You really don't want to push that button, Yolanda? I don't know.
And so what I see different ways to look at generating synthetic data from physics-based models so that the neural networks are learning from more and more larger set of data than what we observe naturally. I see different ways to incorporate knowledge. So I wonder if that's the future, how we try different ways to take these statements and make sure that whatever a large model like GPT is learning, that it is guided by those statements in some way. And the physics laws that I see people in science use, they're relative, they're approximate, they're not perfect, just like our good old symbolic knowledge is. So I wonder if that's kind of another possible.
Yeah, I don't know if this is quite the take that you're trying to pitch here, but theory. So I have good machine learning theory colleagues at UT. I've been arguing with them for 35 years. When did Adam show up? So if people don't know, we have at UT the NSF founded Center for Machine Learning. It's called IFML. I'm on the board.
Yes.
It's led by our theory, and I love Adam.
I don't mean that. I mean,
okay.
by theory, I mean physics or chemistry or, physically grounded knowledge laws of physics that we know that make sure that your model is not learning about the river and makes the water go
Oh.
upstream,
Oh.
right? So that what the model is learning
there's a lot
from
of sense
data
of-
is consistent with the theory or the.
Well, as you certainly know, there's a long history of work in sort of naive physics. One of my former colleagues was Ben Kuipers, right? I lived in an office next to him for 20 years. There's a long history of work on sort of trying to capture common sense knowledge about the physical world and those constraints. And that, it's like to say, how can we take some of that? I've showed you how to take COMET sort of things. How can we take all the stuff that was done on qualitative physics and add that into as constraints on learning models? I like it. Has anyone seen anyone do that?
In science, it's happened.
Yeah, I know there's actually somewhat DOE call that I ended up having to review some proposals for just internally at the university. I don't know if I should be saying this in public, but it's trying to combine like machine learning with good old fashioned like modeling of the climate using differential equations or something like that. Interesting. This is pretty far outside my area of expertise, but I think we can all agree. Yeah, interesting problem. Yeah, incorporating sort of our knowledge of physics with learning from data. People in the sciences, like you said, are working on this, trying to build these models that integrate what we know about the physics and the differential equations with data. Yeah, great area, little far from my expertise, but yeah.
Maybe that's your seventh piece.
Yeah, I don't know. Yeah,
I had a related.
we can stop this whenever. I can go on all day.
Well, we have 3 more minutes.
I need some more caffeine at some point.
Okay, Philip, yeah.
Yeah, hi, I'm Philip. I just had a question. So I was very curious that you started with sort of, Shankian theory. And so that when Yolanda mentioned theory, I was wondering, like, what is the role of these sort of former, like event schemas in, let's say, in the data set that you're developing now or the data set that you're going to develop next? Is it just an inspiration that we kind of took to create Y question and that's where it ends, or is there more into this schemas?
For what I'm saying here, it's the inspiration, the mechanism of how Shankian theory in quotes did this sort of stuff. I do believe, building those graphs. I showed you that graph that my system built. Here's the actions, here's the states, and here how you reason through the answer to get the explanation for how the goal state was achieved. I still believe that I think we need to make better neural symbolic models that can build those sort of interpretable symbolic structures, but build them robustly by data-driven methods and large models. But still at the output, I want to see that nice little graph that my 1987 system produced. It's just, I think I've been very clear. I really believe in this integration of symbolic reasoning with neural nets. And there's a bunch of proposals out there, and I've tried to keep up, but that's whole neural symbolic. Well, you Google that word now, it's like, tons of papers, right? I did a lot of work on combining probabilistic reasoning with symbolic, like Markov networks, and this sort of stuff. I was in that whole space for a long time. And there's a lot of like combining logic with neural nets. Neural theorem proving, now if you know that, that's a cool thing. William Cohen's, I'm going to meet William in a couple of weeks at Pittsburgh. He's done some interesting neural symbolic things. So yeah, I love neural symbolic. And I don't currently have any great ideas of how to go forward, but there's a lot of work out there. And I'm very sympathetic to that type of work. Okay, I'm happy to eat lunch.
So thank you very much. And so we can stop the recording. Most of the people here in person.